Right, so let's just rub this out and I'll just start again so as it kind of makes sense. First question I asked was, what's the probability of us rolling a 6 on a standard six-sided die? And it is 1/6. One option out of the six possibilities. Okay, these are the six different possibilities, and this is how many that we're looking for. So there's only one out of those six possibilities, so 1/6. The next question was, what would be the probability of us rolling two sixes in a row? Well, what we did here is we listed all the different possible outcomes of rolling two dice. Yeah, I don't know, plural of dice. I think is yeah. Anyway, you know what I mean. Two dice then. Um, and if we look at these carefully, we've got six groups of six combinations. It's not that. So just to be clear, then that is one outcome. It's not one of the squares is an outcome. Just both of them together would be one outcome. So we've got six lots of six, so we can see that there are 36 possible outcomes. And the way that we did that is we did 1 over 6 times 6. So essentially the probability is 1 over 36, which, as you can see, is 1/6 times 1/6. So this is what we use this multiplication symbol when we're doing something that kind of means and. Now, what I mean by that is we wanted a 6 and another 6. So when we are trying to work out probability of something happening, we multiply the probabilities. Let's imagine, for example, the chance of it raining on any day is 0.1 or 1/10. The chance of it raining twice in a row, therefore, would be 0.1 times 0.1. So that would be the chance of it raining twice. Now, so whenever we want to work out a combination of two different probabilities of two things happening, something and another, we multiply the probabilities. We could try a different one. Let's imagine if the probability of rain is equal to 0.1, then the probability of dry, basically no rain, is therefore 0.9. So what's the probability of it raining the first day and being dry the second day? Well, it would be 0.1 and, so because we're saying rain and then dry, times 0.9. So we use multiplication when we're using and, basically. Now, what about or? So what's the probability of it being raining or being dry? Well, clearly it's got to be one or the other, so we know the probability is 1. And in terms of the maths, what you do is you add them. 0.1 plus 0.9 does equal 1. So when I use or, I add, and when I use and, I multiply. Let's imagine, for example, what's the probability of me rolling an even number? Well, that's basically a 2, a 4, or a 6. So as you can see, or is being used. We could say 2 or 4 or 6. So we're using or. So in other words, it's presumably going to be the probability of it rolling a 2 plus the probability of rolling a 4 plus the probability of rolling a 6. Well, probability of rolling a 2 is 1/6 because only 1 2 in the six-sided die. And then this is going to be 1/6 as well for the same reason. And this is going to be 1/6. And so we have 3/6, which is equal to 1/2. And that makes sense because half of the numbers on the die are even. So we expect it to be the probability of even to be half. So this is how you use the and or rule in probability. So when you got more than one thing happening. So this is how you use them in probability diagrams. This in tree diagrams. So it's a bit confusing when we don't do it with examples. So maybe we want to look at an example with real numbers in them. That's all a little bit confusing. Try to find one that doesn't help that it's been split over 2 pages. Let me just pause the video a moment. Okay, so I've just taken this from the website. So with tree diagrams, most of the work around conditional probability is done in the diagram. So conditional probability just means what's the probability of this happening if that has happened, or okay, I'll just forget for the moment about the phrase conditional probability. Just imagine one thing happening and another thing. So in other words, we're looking at you have to know a bit about cricket now, don't you? Let me have a look. What's the L and what diagram are they doing? What's the probability we're talking about here? Okay, cricketers looking into their batting performance against left and right bowlers. What complex example to give? Find the first innings of a match. They find they're given out left-handed bowlers 35% of the time. This is a complex example. Let me pause the video and get a better example. We don't want to have to understand the details of cricket to understand this first example. 1 second. So this is a bit better, really. We've got the first thing happening, which is flipping a coin, and the second thing, which is rolling a dice. So probability of being a head is 1/2. The probability of being a tail is 1/2. And then the probability of it being a 6 when you roll a dice is 1/6, and not 6 is 5/6. So what we can do is we can say, what's the probability of it getting a head and then rolling a 6? Well, we follow that part of the tree diagram. So we go, okay, a head, and then rolling a 6. And then we can see, okay, so that's 1/2 times 1/6, because it's and. We're saying this and that happening. What about if I rolled a head and then I didn't roll a 6? Well, that's going to be 1/2 times 5/6. Tail and a 6, 1/2 times 1/6. Tail not a 6, 1/2 times 5/6. So this is how these tree diagrams work. So let's have a look at the first example, first question. I have a funny feeling it's kind of a weird one because we have to identify what is wrong with it. So there are 30 students in Mr. Lear's class. 16 of the students are boys. Two children from the class are taken at random. Mr. Lear draws this probability tree diagrams for this information. So yeah, I mean, we can see here that the chance of the first one being a boy is 16 out of 30, because and we don't need to simplify it at this stage. The fraction. So 16 boys out of 30 students. Girls, 14 girls out of 30 students. You can see that after they picked one of the boys, there are now 15 boys, and there are the same number of girls. Whereas if you picked a girl, the number of boys would be the same, 16. The number of girls would go down to 13. There is a mistake, however, in this diagram. Can you identify what it is? So the mistake is that he was right to notice that the number of boys had gone down if you picked a boy in the first case, and the girls would stay the same if you'd picked a boy, whereas in the case if you picked a girl, the boys would have stayed the same and the girls would have gone down to 13. But it would also not be out of 30 anymore. It would be out of 29, because you picked either a boy or a girl. You still picked one of the students. So all of these numbers here should be 29. So I'm going to just edit that there. In fact, I'm just going to write, let's label it like that. Should be, that's very messy. Should be 29. Okay, so that's the first question. Anyway, I'm going to stop the video and put it there, and we're going to have a look at the rest of them together. Okay.